Okay, let's work this example here. It's asking us for the current immediately after the switch is closed. We have a battery, a resistor, and a capacitor in series. So the minute we close the switch, remember the capacitor acts like a short circuit then. So it's like it's not there. It's just replaced by a wire. So then my circuit is just E and R. And then the current is then what we call I sub 0 is given by E over R. In this case, that's 20 volts over 10 ohms. That's 2 amps. Then it's asking us about the current after the switch had been closed for 0.5 seconds. For that, we need to use the equation for current. I of t is equal to I0 exponential minus t over RC. So in this case, we are looking for I at 0.5 seconds. So that's going to be 2 amps exponential minus 0.5 seconds over R times C. So 10 ohms times C, which is 30 millifarad. So that's 0.030 farad. So it is equal 2 amps times exponential minus 0.5 over 10 times 0.03, so over 0.3. That comes, okay, let's use the calculator for doing that, just to make sure you know how to use it. So I have a calculator here. Let me clear. So what I'm going to do is 0.5 divided by 0.3 and then inverse natural log of that. But since it's with a minus, I need to do the inverse. Okay, let me repeat that. Let me do it some other way. 0.5 divided by 0.3. Let me add a negative sign to that and inverse log of that. See, we get the same thing. Times 2 amps. See there, it's 0.38 amps. The next question is calculate the current after the switch had been closed for a long time. Once you close the switch for a long time, the capacitor is going to act like an open circuit, so there is no more current. So I at infinity is equal to 0. Infinity is signifying for us after a long time. Next question, calculate the charge on the capacitor after the switch had been closed for a long time. The charge on a capacitor after the switch had been closed for a long time, Q infinity is what we labeled as Q infinity, is just the voltage of the source, the maximum voltage that we can have across the capacitor, which is in this case the voltage of the source. Remember the equation, Q is equal to CV. So it's going to be E. Okay, let's look at this question here. Both switches are initially open, even this one here is open. And the question is, what is the current through the battery after we close S1? S2 is going to remain open. S2 remaining open, meaning that this part of the circuit is irrelevant. Now, Now that we know what we need to focus on, we need to know what resistance do we have and what capacitance do we have. In this particular circuit, my resistance is twice R. My capacitance is C. The minute we close a switch for an RC series circuit, the current is the voltage of the battery, in this case E, over the resistance of the circuit, the series resistance of the circuit. In this case, that's going to be E over twice R. So that should be my answer. Now the question is, what is the current through the battery after the switch had been closed for a long time? Okay. Again, remember this part is irrelevant. Capacitor is fully charged, no more current. Now in this case, we are trying to find the charge 3 × 10⁻³ seconds after the switch is closed. We are given the values, instead of saying 2R, we are given the values 40 ohms. The voltage of the source is 50 volts, the capacitance is 100 microfarad, and R1 is 20 ohms. Remember, as long as we don't close S2, this part right now is insignificant. Now, charge in a capacitor, Q is Q infinity times 1 minus exponential minus T over RC. Q infinity, that's the charge in capacitor after a long time. After a long time, there is no more current in the circuit, and the charge in the capacitor is just E times C, which is in this case 50 volts times 100 times 10⁻⁶ farads. So this is 10⁻⁴ times 50, 10⁻�3. So it's 5 10⁻³ coulombs. Okay, my RC is the resistance that's going to be irrelevant in this case is R2. So it's going to be R2 times C, which is in this case 40 ohms times 100 microfarad. So it's going to be 4 10⁻³ seconds. So my equation then, Q at 3 10⁻³ seconds is equal to Q infinity, which is 5 10⁻³ coulombs times 1 minus exponential minus 3 10⁻³ seconds over 4 10⁻³ seconds. Okay, the 10⁻³ cancel out, and then I have exponential minus 3/4. So I go to my calculator again. So I have -3 divided by 4, inverse natural log of that. Take the negative of that and add to it 1. And we multiply that by 5. So our answer is 2.6 10 to the minus 3 coulombs.